26.3 Ellis Stevens. VO2 max is the maximum amount of oxygen that can be taken in by, transported in, and utilised by the body during incremental exercise. Adams et al. 2010. It can also be used as a measure for one's cardiovascular system, respiratory system, and exercising skeletal muscles endurance capacity. It is also useful to take in order to measure one's general health, as having a low VO2 max puts the individual at a higher risk of cardiovascular diseases, as well as increasing the risk of conditions such as prostate, ovarian, and breast cancer, as well as type 2 diabetes. Depending on the sport that the athlete competes in, the VO2 max score that athletes achieve may be slightly different. This will be because of a range of different factors, such as the intensity of the sport they compete in, as lower intensity sports will require a lower VO2 max because the muscles that are working won't need as much oxygen in order to stay working throughout the duration of the sporting event. For example, male triathletes have an average VO2 max score of 80 millilitres per kilogram per minute, while male weightlifters have an average VO2 max score of just 52 millilitres per kilogram per minute in comparison. This is because triathletes' muscles will be working for a higher amount of time, and so the body needs to be more efficient at utilising oxygen that is breathed in during the activity in order to supply the muscles with enough oxygen to complete the event, whereas weightlifters are working for a very short amount of time, and so the muscles don't need a lot of oxygen, and so their VO2 max can be lower. While VO2 max is used to get an individual reading for separate people, it can be taken in a more general manner. This is called absolute VO2, and it, according to Commander 2013, reflects the total, absolute amount of oxygen consumed by a body, regardless of size, age, or gender, whereas relative VO2 indicates that score corrected to some reference, which happens to be a unit of mass, or 1 kilogram. Furthermore, the VO2 measure can be taken using two different types of methods that will give either more or less accurate results, which would be called direct, accurate, or indirect, estimated measurements. Direct measurement is taken through the use of the gas analysis test, which gives a direct measurement as it directly measures the volume of gases inhaled and exhaled by the participant through the use of a Douglas bag. An analysis can then be done on the contents of this Douglas bag to get a direct measurement for the participant's VO2 max, whereas indirect measurements are when an estimate of a result is used in order to calculate one's VO2 max, and so this measurement may not be completely accurate due to the estimation of a result. Within this, there are many different tests that can be carried out that will give an indirect measurement for one's VO2 max, with most of these estimating the participant's VO2 max for the use of measurements such as heart rate. This is often used because heart rate and VO2 max have a linear relationship at submaximal levels. These different types of indirect tests can be either maximal or submaximal tests, with some of the maximal tests being the yo-yo test or the multi-stage fitness test, while some of the submaximal tests are resting heart rate and max heart rate, or the Queen's College step test. Maximal tests are those that require the participant to push themselves during the test to the point of exhaustion, where they cannot continue in the test for any longer, while submaximal tests don't push the participants to their maximum capacity, and so all participants should be able to easily complete the test. As previously stated, the only method that can be used to find the true VO2 max of an individual is by carrying out the gas analysis test. This is backed up by Wicks et al. 2016, who states in his study, which is based around the comparison of results from multiple methods of the gold standard gas analysis, that the only way to ensure an accurate measurement of VO2 is direct measurement with gas analysis. Furthermore, Santilla et al. 2013, who was carrying out a similar study to Wicks, stated that throughout the study, direct oxygen uptake was measured continuously using a gas analyzer, which has been shown to be the most valid instrument for measuring respiratory gases. The agreement between these two separate studies and the fact that the gas analysis test is reliable and accurate in giving results for the VO2 max of individuals shows the high reliability and validity of the test in question. Furthermore, the reliability of the results can be further supported by Duffield et al. 2014, who states that satisfactory test-retest reliability of the system was demonstrated. Despite all of the evidence from these studies to suggest that this method is faultless for giving an accurate and reliable reading for individuals' VO2 max, there are some studies that argue there are some faults included within this test. For example, Chin et al. 1986 stated that there were some errors in analysis which were due to unsatisfactory calibration of analyzers. This shows how there are faults when carrying out the gas analysis method, and in particular the fault is because the analyzers were not correctly calibrated prior to their test being carried out. However, it could be argued because of the time since Chin's study and the advancements in technology that have happened since, that the argument should not be considered when looking at the reliability, accuracy, and precision of newer modern technology. To any of the testing taking place, there were multiple pre-test measures that had to be put into place. The first of these was a health screening questionnaire that all the participants had to fill out, which contains multiple questions that once answered would determine whether the participant is in good enough physical shape and healthy enough to take part in the testing. Furthermore, an informed consent was required to be signed by the participant in order for them to take part, which outlined the protocols of the test they would be doing, and also stated that the participants were volunteering to take part and they understood the risks that they were involved in the tests. Finally, a risk assessment was completed for both of the tests that would be carried out, as this allows for the researchers to prepare for all of the possible risks that may occur during the testing and try to prevent these from happening by putting some protective measures in place. In this study, the MSFT and Queen's College step test were used in order to get two different measures for the participants' VO2 max scores, using one of the maximal and submaximal tests. To carry out the multi-stage fitness test, there is a number of different factors that must first be ensured are in place, such as ensuring the running distances be marked out as 20 metres and cones put at either end, and also that the multi-stage fitness audio tape has been set up. Once this is done, the participants will be able to line up at the start line, and the audio tape can be started. When the participants hear the first bleep, they can start running to the other end, where they must get to the cone before the bleep, and can only start running back to the opposite end once they hear this bleep. If the participant fails to reach the opposite end before the bleep is sounded, then they have 2 to 3 more attempts to catch up and beat the bleeps before they are taken out of the test. This process of running to and from each end should be continued until the participant is physically exhausted and can no longer continue, and so drop out. This is the point that the level and shuttle should be recorded. In order to get the participants predicted VO2 max on this score, a conversion or table can be used from the internet. The Queen's College step test is similar to the multi-stage fitness test in the aspect that there is some prior setup that must be carried out before the test can be successfully carried out. This includes measuring a 41.3 centimetre high step for both men and women, and ensuring that the correct metronome is used for both men and women, with men having a 24 steps per minute pace, or 96 beat metronome, and women having a 22 steps per minute pace, or 88 beat metronome. Furthermore, a stopwatch must be present to record the 3 minutes that the test must be carried out for. However, one of the most important things that must be in place is that it should be ensured that the participants haven't exercised for 24 hours and have fasted for 2 hours prior to the test. Once all of this is in place, the participants should take their resting heart rate and record this result. Then the actual test can take place, where the participant should make contact with their foot on each one of the beeps with their feet following the pattern up, up, down, down. Once this has been completed for 3 minutes, the participant should then take a reading for their recovery heart rate. The measuring of the individual heart rate should be taken by counting them for 15 seconds and then multiplying the value by 4. Results. After the participant carried out both the multi-stage fitness test and the Queen's College step test, there were 2 results for the participants' VO2 max. There are different ways that this VO2 max score is calculated from the results the participants achieved in both the multi-stage fitness and the Queen's College step test, as both use opposing equations to calculate their score. For example, the multi-stage fitness score is calculated by using an equation that was created by Kilding et al. 2006, which reads as follows: VO2 max equals 0.38 times total number of shuttles completed plus 25.98. It is important that this equation is carried out correctly, as if this is not done, then the result for the VO2 max will not be accurate and truly represent the score that they have actually achieved. However, in order to do this, the correct number of shuttles must be calculated. This can easily be done, as the multi-stage fitness test is measured in levels and shuttles within these levels, and so to get the total, the level achieved should be turned into the equivalent number of shuttles, with level 1 being 7 shuttles, 2 and 3 being 8 shuttles, and this pattern is then followed where every 2 levels has an increase of 1 shuttle. Despite this, an online calculator can be used, which just requires the age, gender, and number of levels and shuttles to be input, and the VO2 max score can be calculated, or a generic table calculation can be used, which has VO2 max scores being in line with a specific number of levels and shuttles achieved, as seen in Figure 2. However, the Queen's College step test uses a slightly different equation, with this equation also varying depending on the gender of the participant. Therefore, the equation used for males is VO2 max equals 111.33, take away 0.42 times recovery heart rate in brackets, and the equation for females is slightly different, as it is VO2 max equals 65.82, take away 0.1847 times recovery heart rate in brackets. Similarly to the multi-stage fitness test, this equation can now be done electronically by using an online calculator, which just requires the 15-second recovery heart rate and the gender of the participant. This process was carried out for both the participants' tests, with the participants' VO2 max being 39.9 for the multi-stage fitness test and 57.6 for Queen's College step test. According to Quinn et al. 2019, the average sedentary male will achieve a VO2 max of approximately 35 to 40 milliliters per kilogram per minute. This shows that the client's health is very good, as their lowest score, 39.9, is at the top of this bracket, and their highest score, 57.6, is much higher than this bracket. However, compared to the participant's sport, which in this case is football, the participant is sitting below the average, as according to Douglas et al. 2012, the average player had a VO2 max of 62 to 64. From these comparisons, it is clear to see that while the participant may be considered very healthy due to their VO2 max scores, they are still under the ideal VO2 max score for their sport. However, due to the large discrepancy between the two results, it is hard to compare these results to the health and sport specific normatives, as it is unknown which result is closer to the true value. Despite this, it is still evident that the participant is sitting below the ideal VO2 max for footballers, as even their highest score of 57.6 is still below the average of 62 to 64, and so it would still be recommended that participants train their VO2 max in order to help improve their performance in the sport. This is because the participant in having a lower VO2 max than the ideal score for football shows that a body's utilisation of oxygen is worse than it should be, and so they may not be as fit as other people with scores in the ideal range. This would have a negative impact on the participant's performance, as it means that they'll become fatigued and tired quicker, and so won't be able to play at their normal level for as long due to the quicker onset of fatigue in their muscles due to the poor VO2 max score. Therefore, it would be suggested for the participants to improve their VO2 max score, as this will help to delay the onset of fatigue in the muscles, and so they will be able to complete at a higher level for longer than they would if they did not train their VO2 max score, and so their overall performances would increase. In order to do this, it would be advised that the participant carries out a form of interval training, as this would help to increase their VO2 max. Within this, the participant should run 800 metres at a fast pace, and then reduce the pace to a light jog for 400 metres. This should then be repeated 2 times in the first week, and gradually build up the speed and distance the participant is running until the 6-week point. This would allow for the participant to quickly increase their VO2 max, and therefore their endurance will increase, and so performances will not be hindered due to fatigue occurring quickly in the game. Furthermore, the participant should do 2 sets of battle ropes at maximum intensity for 15 seconds prior to completing the interval training that is stated before, as this will also help to increase the aerobic capacity of the participant and also their VO2 max.